Good afternoon, everyone.
Good afternoon.
Okay, can you all see my screen?
Yep.
Yep.
Okay, very good. Okay, so let's get started. I will try to have the exams graded by Tuesday. I've started grading them, and some of you have probably noticed that your scores are starting to jump around a little bit as I grade them. And I still have one exam that I have to give after class today, so I can't go over the answers just yet. What I'll probably do is release the answers over the weekend, provided I don't have anyone else come and tell me all of a sudden that they missed the exam and didn't realize it. But I think the makeup I give after class today will take care of all the makeups. And as I said, I'll release the solutions once that is done, and then I'll probably go over the solutions also on Tuesday in class. Also, for those of you who really dislike using Respondus, for the final, I anticipate that there will be an in-person option. Now, I know some of you are not on campus or not in Knoxville, but for those of you who are in Knoxville, I do plan to give the final as an option in person at MinGal. So that will be a possibility. I don't think I have announcements beyond that. I believe that the next homework assignment is not due until essentially a week from Sunday night, so March 22nd. And that is because we are going to be spending about 2 weeks, 2 more weeks, a week and a half, going over graphical user interfaces, and you'll be able to do part of the homework after today, I believe, but part of it you'll probably have to wait till we get to the MVC model and custom painting and event handling. So as I indicated before the exam, we're actually pivoting now. And for the next 8 weeks, we're going over 4 programming paradigms: graphical, event-based programming. And as an example of event-based programming, we're using graphical user interfaces, but simulations are another big example of event-based programming, and so are animations. Then we will move on into scripting languages using Python as the language we study. Then we'll come back to Java, and for 2 weeks we'll be looking at concurrency using threads and how you can distribute a computation in Java with its concurrency mechanisms. And finally, we will end with functional programming and be looking at a dialect of Lisp called Scheme. So we have, in the graphical user interfaces, we've already covered the introduction and talked about widgets. Actually, did not get to message dialogues at the end of the last lecture. So we'll start with that, and then we'll talk about layout algorithms for widgets, which is what is the big topic for today. So there is something called a J option pane. Unfortunately, I threw out my original notes I'll go to. So there's something called a J option pane that gives you a way to pop up message boxes for a user. And it essentially pops up an informational box. So let's go and it'll pop up a message box that looks something like that. Okay, so when you get dialog boxes like saying, are you sure you wanted to delete something? Yes, no. That's what we're talking about with a message box, something that pops up. And they provide 4 types of messages. Informational, so that's just something telling you, for example, maybe that your appointment has been confirmed for March 30th at 5 p.m. A question, that'd be something like, are you sure you want to delete this? Yes, no. And then warning and errors are meant to indicate something that could not be, well, an error, something that could not be completed. A warning, something to let you know that perhaps the operation was completed, but something went wrong. And the J option pane class has a method called show message dialog. You give it the window with which this message dialog is associated with. So basically, you have to add the option pane to the content pane for that window. And you don't do it, but it's done for you by Java. And it does that by making you associate the message dialog with a particular window. Then you give it the message or question that you want displayed. And this is the name, oops, this is the title of the window. So right here, that would be whatever showed up in the title for the window. And then I said there were 4 informational types. This is a warning message. So there's 4 constants corresponding to informational message, question, warning, and error. By default, you can omit this and it will be an informational dialogue. And these are what are called modal. So you will often hear the word modal used in GUIs, and it means if something is modal, it means that operations stop. So the application stops until the user deals with the message box. So this is somewhat unusual. Generally, GUIs are not modal. Usually, when one operation is being performed, you can go ahead and perform other operations. Like on the desktop, I can be downloading something in Firefox and move over to the terminal window and do something in the terminal window. So modal means that the application actually grinds to a halt until the user actually does something. So message dialogues are modal. They will actually stop the application until the user presses one of the buttons that pop up. And I didn't show it here, but you can also sometime, maybe I did, nope. There's a way to also indicate what are the labels associated with the buttons. Let's see if I can, there's an example quickly here where they show. These are all okays. Here we go. So you're allowed to create an array with the names you want applied to the buttons. And then as part of the showing the message dialog, you're allowed to give that, whoops, I'm sorry. You're allowed to give that array and it will label the buttons with the labels in those arrays. And then you can also give the default selection, which in this case is the last option, which is no eggs, no ham. Okay, so you can look at the documentation for creating these message dialogues. I don't believe you have to create them in the homework assignment, but I wanted to make it clear that those widgets were available for you if you needed them. Okay, so let's move on and want to talk about layout managers. So in a graphical user interface, you may have some items that you want laid out. And generally speaking, you don't want to lay them out by hand. Now, it turns out that many integrated development environments let you lay out things by hand. But things laid out by hand have some drawbacks. First of all, what do you do when you resize the window? Okay, so when you resize the window, how should the items be relayed out? Okay, if you manually specify the layout, that's pretty unclear what is supposed to happen when you resize the window. Another issue, what if you later add another component? Or if you delete one equally. So let's say I want to insert a new component right there. Well, that may, if we've laid it out manually, we're going to have to go back in and start manually moving things around. Like we'll have to manually move this somewhere else to create space for this new thing that we're putting in. Okay, so manually laying out windows is frowned upon. And instead, Java provides a number of layout managers, which are algorithms that automatically lay out the window for you. And specifically, they assign a space, they assign three things to each element. They assign space, a position, and a width and a height. So space is sometimes you get a larger piece of real estate than what you want to display yourself in. So for example, let's say that I have two buttons, okay? And this is their natural size, B1 and B2. And I want to lay them out in the window of this size. Well, clearly this window is bigger than these two buttons. So what might happen is the space, the upper space might be assigned to B1 and the lower space is assigned to B2. And they might be assigned this particular width and height and this particular width and height. So then the space allocated to them is bigger than their width and height. So the position then becomes where are they placed within the space. So one possibility is it is put in the upper left-hand corner. Another option is centered in the box. Another one would be that it would be nailed to the top and centered. So those are all different options for where you would put it within that space. So that's what I mean when I say space. You make it a piece of real estate that is bigger than your width and height, and then the position is where you are located within that space. Okay? So the issues faced by a layout manager are the following. So what a layout manager, issues for a layout manager. So each of them is an algorithm for laying things out. And the issues they face is how to assign a position, Then how to assign size. How to assign space. How to align the object. If its space is larger than its size. That's what I just showed you, that options with the button B1, you could put it in different places. And 5, how to resolve issues 1 through 4 when the window is resized. So Java provides a number of layout algorithms for you. There's something called a border layout. There is something called a grid layout. Something called a flow layout. Something called a box layout. A JTable, which lays things out as a table, and a grid bag layout, which you also have seen. So these are different layout managers that we will go over today. And they have different ways of arranging items in a window, or actually in a container. So in Java, what happens is you have this notion of containers. So Java has containers, and they consist of, composed of objects. And each container has a layout object associated with it. Now remember, in Java, you can't have standalone functions. So each of these layout managers is implemented as a method, but it can't be implemented as a standalone method. Instead, it is placed inside of an appropriate layout object, and then the layout object is assigned to the appropriate container. And the layout object generally contains parameters that the layout manager will use. For example, gaps between components is one important thing that many layout managers want to know about. And so the layout object contains parameters. So a layout object contains parameters, a method that implements the layout algorithm, and any state information that the layout algorithm computes as part of laying out the container, the components in the container. That and then another thing that that Java has. So you have a container composed of objects. So each component is able to specify 3 other items. So each object specifies a preferred size a minimum size and a maximum size at which it wishes to be displayed. So the preferred size is the so-called natural size. The minimum and maximum size is the minimum size that a component is willing to be shrunk to. The maximum size is the maximum size it's willing to be expanded to. And sometimes you will say that the preferred size is also the minimum size and the maximum size, in which case it won't be expanded. So going back to my previous example here, in this example, I was assuming that the button asked to be displayed at its preferred size and made its minimum and maximum size the same. If instead the button had said that it could grow infinitely big, then it would have been no problem. The button simply would have been made as big as the space allocated to it. So these are not requirements, they are suggestions, okay? So they are suggestions. The layout manager is free to ignore, okay, suggestions to the layout manager, but layout managers may ignore these suggestions. Now, when the layout manager first lays out a window, it tends to lay everything out at its preferred size. So in fact, generally, when a window is first created, everything is in fact shown at its preferred size. But this comes into play when a window is resized. And helps the layout manager decide what to do when either additional or less space is given to various, or is given to the container. Okay, so that is the general principle. So going back, every Java container has a layout object associated with it, and there is a default layout manager, and it depends on what kind of container is created. So I think a JPanel by default uses a flow layout manager, and a content pane for a frame, I believe by default uses a border layout. So there are default layout objects already associated with a container when you create it. So again, these layout objects contain parameters, methods that implement the layout algorithm, state information, and then each object individually specifies a preferred size, a minimum size, and a maximum size. Okay, so then what normally happens with a layout manager when it's invoked, a layout manager usually makes two passes. So the general strategy is that it starts with a bottom-up pass. So it asks each component for its preferred size. And it aggregates these sizes. Okay, and then the second thing it does is make a top-down pass where it actually assigns each component its space, position, and size. And remember, a component is itself allowed to be a container. So you may be passing this information down. One of the components or multiple of the components may be containers. So those containers will in turn kick in their layout managers at that point to lay out their components. So it's kind of a recursive thing. So it's like here we have the top level. This one might have some other components. So this one would have a layout manager. This one would have its own layout manager, which might be different than the layout manager for the top level. So when this component gets its size, space, and position, it kicks its own layout manager in then to assign that information to each of its subcomponents. Okay, so that's the top-down pass that I was talking about. So questions thus far about what I've covered? Okay.
It's fairly straightforward.
Oh, yes. Yep. Hopefully fairly straightforward. Okay, so let's just look at some of the layout managers. So we'll start with the border layout. So these were some of the ones that we were talking about. And so what I'm going to do is demo them for you. So here's a border layout, and I'm going to immediately make it bigger. You can see as I make it bigger, the center is taking pretty much all of the extra space. You can see that the north and south are not changing in height, but they're changing in width. And you can see that the east and west are changing in height, but they're not changing their width. So basically, the border layout is saying, I don't care what the maximum size is for or minimum size is for the center object. It will essentially get all of the space that is left over. For the top, north, and bottom, it will respect their natural height, but it will not respect their natural width. It will make in this case, I have buttons. These are buttons, and it made the buttons be as wide as the window or as the container. Same thing with the buttons on the left and the right sides. It respected their natural width, but it made them essentially as tall as the window, although they end it at where the north and south buttons started. So this border layout is typically used at the top level for the main window of an application where you're putting tool palettes. So you use a border layout to put tool palettes around the side and then the main window, like a drawing window, in the middle. And it has 5 regions, exactly 5 regions. A left, which is often called west or line start, line ends for being the end, page start for the top, page end for the bottom, and center. The old ones used north, south, west, and east. The only problem is in some countries, the order changes. And so they figured it was better if you used line start and line end, so that in countries where it goes right to left rather than left to right, they could be easily swapped. Okay, so 5 regions, you only basically get 5 items that you can insert. So let's just take a look at what that looked like, the code for it. So you can see that I create a button, my first button, and I added it using the add method. So the add method adds things to a container. So I'm adding the button and saying that I want it added at border layout.page start, meaning I want it added at the north part of the container. Then my second button went to the center. You'll notice I set the preferred size to be 200, 100, so that when the window initially came up, it was at that initial size. So if we go back for a moment and kill it, run it again. Initially, this was 100 by 200 on my screen. Okay, so this was driving the initial size. If I had not put that preferred size in, I'm going to comment it out. It will appear at its natural size. So I'll compile the border layout demo. You see now it was much smaller because the middle button was displayed at its natural size rather than that bigger size. But still, when I resize the window, notice that it is being forced to get as big as the window. And you'll notice the label is being anchored at the bottom and centered. So here it's getting more space than it wants, and it's saying, okay, I'm putting the label therefore at the bottom and centering it. That's the alignment that it's choosing. So I'll take that out, and you'll notice here it is, button.set vertical alignment to be bottom. So it was saying if it got more space than it needed, it should be aligned on the bottom. Okay, and then we added it in the center. Same thing for the other three buttons. They were just added in their appropriate place as well. Then you see we created in our setup function, we created the frame, and we called add components to pane. That was the function that added the components to the content pane. And then these two commands are really important, frame.pack and frame.setVisible. So frame.pack, the pack method invokes the layout manager and causes it to compute the initial size of the window, and then frame.setVisible sets it to be true. A common error is to forget to call the pack command. Okay, so I am going to recompile this having forgotten the pack command. And it's like, where's the window? It is right here. Whoops, nope. It is right there. I can't see how it now is expanding. But the problem was because I didn't pack it, it assumed the size of the window was 0. We'll redo that. I didn't call pack. See, border layout demo, it's there. It's right here in the corner, but it's a marginal size because I forgot to call pack. Okay, and then I can, whoops, I can, there, I can grab it. Maybe, yes, I can grab it and make it bigger. Okay, so this pack command, really important. You make sure that you call it right before you make the frame visible. If you forget the pack, you're probably going to get a window of essentially 0 size. So when you see that in your homework assignment, just know that you forgot to call pack. Okay, so that's the border layout. And one thing that you can do with the border layout is you can specify gaps. So let's see if I have the other. Nope. You can specify gaps. Let me show you the grid layout so you can see the next one. So grid layout allows you to lay things out in a grid, and you often use them for tool palettes because everything appears at the same height and width. So every element in the grid has the same height and width. So if I resize it, everything stays the same. In this case, height and width. And you can see here, it was making the buttons wider, but keeping them at their natural height. I'm also allowed to put gaps between them. So here I put gaps, and you'll notice that the gaps did not affect the size of the container. All the gaps did was affect the size of the button. So it made the button smaller in order to accommodate the gaps. So here, I'll make the big, and the vertical gap bigger, and the buttons get smaller. Okay, so they still get the same amount of space, but the gaps between them become bigger. Actually, the main container, this main container with the border, stayed the same, and then the buttons became smaller as bigger gaps were put between them. So the grid layout, every button appears with the same, every component appears with the same width and height, and the size of the grid is determined by the maximum sized width and the maximum sized height. So in this particular case, when I first created it, the width of everything was determined by this long name button. Okay, otherwise, like 5 was made big enough because its natural width would only be big enough to accommodate the 5 plus a little space on either side, but long name button needed more space. In fact, you'll notice it's abbreviated, so apparently there was some limit on the space. And then as it got bigger, you'll notice it was able to display the entire label. And you may wonder, what is with this big blue border? And this is how you debug your layouts with graphical interfaces. You put big colored borders around them so that you can see how much space they are occupying. So when I originally ran this demo, it was without the border. So I'm going to whoops, I'm looking at the wrong file. So you'll notice here I was adding to a container set border, border factory got create line border, color dot blue 5. So originally I did not have the border here. And when I ran it, and resized it, I was confused because I thought that normally the grid layout will also make the buttons get bigger, that it would make it occupy this complete space. So I wondered what was going on, if truly it was somehow going all the way down to here, but it was just leaving this space right here empty. And so to answer my question, I added that border. And what it told me was, in fact, no, it was not extending all the way down to here, that it was stopping right there, which had me a little confused So I did a little more digging because I had taken this demo from the Oracle website. It turned out this was the problem. The top level was using a border layout, and it was only the container object in the north. The container object in the north was using a grid layout. So the separator in the center was not showing up, but it was getting a lot of the extra space. In fact, it was getting all of the extra vertical space. So that's what was going on, is the separator was causing me some grief.
Can you go back to the line that showed that box?
Yes.
Is that the only line you had to add?
Yes. So Border Factory is a class that allows you to create line borders with different sizes, textures, and color. So in this case, I created a line border with blue with 5 pixels wide. And then that returned an object that I used to call, that I passed to set border. And that container object thereafter had that big garish blue border around it. So first thing to do when your layouts are messed up, and they will get messed up a lot, is to put borders around your objects and your containers, because that gives you a lot of information about how things are being laid out. So debugging, I can't emphasize this enough. When debugging layouts, put brightly colored borders around your components. And that will often show you what is going on, because often you make assumptions about how much space. So what this does is it tells you how much space is being allocated to your objects. Because what may happen is you see a button B1 and you're not sure what's going on, but when you put a border around, you find, oh, it's actually occupying that much space. So the borders often show you how much space. So borders can show how much space being allocated. As opposed to size. So space is important. Okay. So let's see. So that was border layout, grid layout. Then we have, I don't think I have flow layout because it's such a, we do, but not. So flow layout, I don't have an example of it, but it's very simple and it's not used as often. So what flow layout does is it lays things out left to right. So it's a horizontal layout manager. That lays out objects left to right. And creates new rows when it runs out of space. So for example, if I had to lay out these three objects in a window that is, say, this big, then this object could get into the window, into the first part. This object could also get in. This object maybe could get in, but now the fourth object, so this is 1, 2, 3, 4, 1, 2, but the fourth object can't, and so would actually be placed in the next row. So it's very simple. As the window is resized, it simply relays things out according to the width. So it always lays as many items out in the first row as it can until it runs out of space. Then it moves to a second row, then to a third row, so on and so forth. It tries to preserve items at their preferred size. You can specify the horizontal and the vertical gaps between columns and rows, but it tends to not be particularly useful. Okay, so instead, a more sophisticated manager that is more often used is the box layout manager, and that allows you to lay out things either vertically or horizontally. And it tries to respect preferred height and width. So it tries to respect when resizing resize horizontally, resize horizontal. It will increase, it will respect preferred height. And enlarge object up to maximum or minimum height. And the same thing with vertical. When resizing vertically, it will respect preferred width and enlarge objects up to maximum, or I'm sorry, back here, this should have been width. And this is maximum or minimum height. So it will expand objects in the direction that you're moving and respect their height or width in the direction that you're not moving. So I have an example. So here's a vertical stack. And as I move to the left, you can see button 3 got bigger for a while because it was willing to take more space, but eventually it reached its maximum and it no longer got any bigger. As we go vertical, notice button 3 getting bigger, getting bigger, getting bigger, getting bigger, and it never actually runs out of space. Okay, but as we get smaller and smaller, you'll notice eventually it goes back to its minimum size. And as I get smaller and smaller, I have to start cutting buttons off because I can't decrease the size of the buttons below their minimum size. Same thing as I go, start decreasing, button 3 will start getting smaller and smaller. Watch long name button 4. It's going to start losing. See how it went to dot, dot, dot? Now buttons 1 and 2 are going to get, nope, I got frozen. So now it wouldn't let me go any further because I hit the minimum size for buttons 1 and for a button. Okay, so if you're looking for a layout manager that will respect your width and heights and preferred width and heights, the box layout manager is a very nice way to go. So if we look at that, first we're going to look at button 3. Yeah. Huh. Trying to find where the preferred size is. Not what happened. Somewhere there should be a maximum. There it is, right here. Button 3, what I set its maximum size to be new dimension 300, 500. So I must never have gotten to the point where its maximum dimension was 500. So there was a limit on how big it was supposed to get. Let's just experiment for a moment. I'm going to make that maximum dimension be just 200 and see if that changes what happens as I resize it in the vertical direction. Yes, so there it eventually, notice how it eventually stopped expanding. So before it was just that at 500 pixels, I never reached the limit of where it would stop. Okay, so.
Did you have to make button 3 final just so you could change the sizes of it? Because it looked like the 1, 2, and 5, you just did add a button and that was the end of the story.
Yes, okay, so there's a little more to that story than meets the eye. It's right here. So we haven't really talked about events yet, but a sec, watch this. If I press button 3, it says button, it propped up a message saying button 3 pressed, okay? Which is not true for any of the other buttons. Notice that? So
yeah, so you just did, sorry.
So what I needed, so this action listener is performing an action on that button. If I don't make it final, the deal is this action listener survives beyond the lifetime of this particular method. So if I didn't make this button final, then when I exit it, this function, this variable goes out of scope. And when I execute it, this action listener later, because this action listener is not gone out of scope. So the problem is it still wants to be able to refer to button even after this method has exit it. And so the way we allow that to happen is we declare button to be final. Does that make sense? I know that's may not be an easy thing to grasp.
Yeah, thank you. That makes
Okay.
sense.
That's what's happening. So this is not final the way that, so sometimes you use final to say that you can't override a method, or you use final to say that it's a constant. This is, I think it's declaring it as a constant, but it's also saying that it will stick around after the method has exited. Okay. So I actually don't want to go over event listeners right now, but this does,
So-
I will just say quickly, this is how you are able to respond to events. You add these event listeners, and then you create these callback methods that are able to respond to an event. Sounds like someone wanted to ask a question.
So does final then kind of behave like extern in C?
I don't, in
where you can
some
access-
sense, yes, but it's mostly in a way, in the sense that it becomes visible now to these nested anonymous classes that you're creating. So what I was really doing here was creating a nested anonymous class. And so effectively it was externing it to that nested class, but it's not going to be visible to things created outside this function. It's only visible to things created inside this function.
So like add a button can't see the J button declared in add components to pane.
Here, you're saying,
Private static J button, the entirely differently declared function.
yes. So add a button can't see it. It's only
Okay.
these internal nested methods that can see it.
Okay, that makes
Yeah.
sense. Thank you.
You're welcome.
So it still respects the scope of the method in which it is.
That's right. So exactly, it's still respecting the scope rules for the method, which is
Okay,
not
thank
like C, right? Because an extern actually says you can now see the variable outside the file. So it's it's slightly different. Okay, other questions? Okay, notice here when I created the layout, I create a parameter saying that in this case, I wanted it to be a vertical layout with the y-axis. I also could have said page start, which would have made it, or page, I think, I forget what, page axis. If I said page axis, it would have also made it vertical. Line axis would make it horizontal. So the other thing that you can do with box layouts, let's see if I have another box layout. Nope, that's the only one. Okay, so something else I can do with boxes is I can create what is called rigid space and glue. And it may be, let me find the Java box layout tutorial. Easier if I find them here. Okay, so you're also able to create what are called rigid areas and horizontal and vertical glue. And these are objects that are invisible but take up space. For those of you familiar with LaTeX, it sometimes uses glue objects. So these are spaces that are invisible, but the glue objects, horizontal glue objects are infinitely expandable and compressible, so they can get all the way down to 0 in size and can get to be infinite in size. Vertical can get to be 0 in height and infinite in height, so they're vertically infinitely expandable and vertically infinitely compressible. And then rigid areas specify an actual fixed size gap with both a height and a width. Normally, you only specify a non-zero height or a non-zero width. That is, generally, it's going to be either a horizontal gap, in which case the height is 0. So you would say, for example, new, you say box dot create rigid area, and it would be new. You give it a dimension object. So be nice if it just took width and height, but it doesn't. It takes a dimension object. So this would say it's 10 pixels wide, 0 pixels high. Conversely, if you wanted one that was 0 pixels in width and 10 pixels high, you do it that way. And you use a dimension object. Why, I don't know. I wish they'd just let you specify width and height, but they don't. And you can add them to your containers just like any other type of object. So the rigid areas will take up exactly that much space. The glue will be expandable. So I will do that in my drawing. I'll create a rigid area in my box demo. So between the long buttons, I'm going to do a pane dot add, and it's going to be box dot create rigid area, new dimension. We'll make it 0 because it's a vertical. Not sure that I have dimension in here, so I think this is going to get me a compile error. Not find symbol box. So I have to import a box. And I'm going to have to find where there's an object called box. And I have to figure out where to import it from. How about looking for import? No import statements? Okay, it's annoying. See where it comes from. javax.swingbox, okay. So we have dimension. Here's dimension right here. That should take care of the box. Cannot find symbol. Java swing x swing. Java x.swing. If I could only not do things with typos. There we go. Notice there's now a 30 pixel gap right there. Okay, now let's say that I add some glue. So right now, when I expand these things, button 3 gets bigger, and then everything goes to the bottom. Okay, now what I'm going to do is I'm going to put a glue object between button 2 and button 3. And to do that, I'm going to create glue. So it's going to be create vertical glue. So between button 2 and button 3, I'm going to add box.create vertical glue. And now, oops, when I resize it, notice that the gap is between 2 and 3 because the vertical glue is taking all of the space. And if I have more than one vertical glue, they will divide it evenly. So if I put a second vertical glue in there, and now I put it between buttons 1 and 2, now you see it's evenly given to the space between buttons 1 and 2 and button 2 and 3. So box layout is a nice layout manager because by using those glue objects and those rigid areas, you can get a lot of nice control over the spacing between objects. So it is a pretty popular layout manager. Then the remaining two layout managers, the JTable and the grid bag, they are much more complicated and they're beyond the scope of this course. Okay, so we're not going to talk about them or hold you responsible for them. You did see an example in the write-up today for the grid bag layout because it is a very handy layout manager. So grid bag layout, in fact, is fairly often, okay, is used a lot, used frequently for dialog windows. So the complete, if you have a complete window, then the grid bag layout is actually commonly used for the window. And then things like flow layout, box layout, grid layout are used for the individual components in the window. And it lays things out in a grid like the grid layout, but it's a lot more flexible. Like in the grid bag, you can have different sized rows. So this could be one sized row, this could be another sized row. They don't have to be the same size. You're allowed to have things span columns. So this one is spanning 3 columns. You could also have things span multiple rows. You can specify anchor points like the bottom or the top. So there's a lot of customization you can do with grid bag layout. And if this were a GUI course, we'd go over it, but you don't need it for this course. It's just a little too much for this course. So we're not going to cover it. But going back, I do want to quickly say when you use these things. So border layout is typically the top level window, and it's good for putting tool palettes around that window. The grid layout is good for tool palettes, for specifying the layout inside of a tool palette. Flow layout and box layout are good for groups of related widgets, like say radio buttons. Say a group of radio buttons or check boxes, text boxes, etc. So good for grouping those. JTable is good for data. Grid bank layout, as I said, good for dialog boxes. Okay, so just a couple more quick things and we'll be done. When you resize a window, that automatically calls the layout manager, and the layout manager relays things out. But when you add or remove something after you've created a window, so let's say you have created a window, you call pack, and now later you add a new component. In this case, for some reason, Java forces you not just to call add, but let's say I did a pane.add and I add some component. I also at this point need to call pane.revalidate. To tell the layout manager to relay out the pane's components. So it's not like pack. Pack will, if you call pack a second time, it will revert a window you've resized to its original size. Revalidate simply says, invokes layout manager on components container. So what that means is, let's say this is your top level content pane. And then here is some object P1. And originally it had items or objects 01, 02, and 03. And now you add a new item, new 04. When you call revalidate on P1, it will lay out these 4 components now in the same space that it originally had. So it will not cause content pane's layout manager to be called. Instead, what revalidate does is relays out the components container using its existing space. So it's not getting any new space. It relays it out using its existing space. Okay, and then after you call revalidate, you also need to call pane.repaint. And what that does is it tells the Java runtime environment that it needs to redraw the window. So if you just call revalidate, it will not actually redraw the window, and you'll be wondering, why does my new component not show up in the window? So after the fact, you have to do, after you've created the window and displayed it, if you add a new component, you have to make sure that you call revalidate to get the layout manager to recompute the space. I'm sorry, to recompute the layout in the existing space. And then you have to call repaint in order to get the Java runtime interpreter to redraw the window. Okay. Questions about any of this? Because we've certainly covered a fair amount today. Okay.
I'm probably just gonna have to watch this lecture a couple of times.
Yeah, and I think the big thing is you should play with them. Actually, I can upload the different demos that I have, because I think you really, the best way to understand this stuff is to play with it. Watching it really doesn't give you a true flavor of what's going on. Playing with it does. So I'll upload my demos to Piazza later today.
When we build this ourselves, do you recommend we have the lecture notes open in another window or the API open in another window?
I would say probably the API in another window, because what I just did was cover more of the functionality, but I didn't cover the syntax. So
Right.
the API will give you the syntax. I just gave you the broad outlines, because drilling down into the syntax would have taken way too much time. So yeah, I'd go with the API open in one window.
Okay.
Other questions? Okay, in that case, I will see you all on Tuesday. Have a good weekend. As I said, I don't think that as of yet you can complete the homework assignment. Instead, you can probably get started on it. I'll take a look, see how much you can do, but I think that's limited thus far to what you can do. I have one student who needs to make up the midterm, so if that student could hang around, I would appreciate it. And otherwise, y'all are free to go.
Have a good weekend, everyone.